yesterday, you didn't have school. Monday, in 5.1, we looked at scale factor. We talked about how your scale factor is your multiplier. It's either going to reduce or enlarge your image, or your location of your point, whatever it is that you're scaling. Now, what we're going to look at in 5.2 is also dilation. So we're still talking about scale factor, but our center of dilation is not at the origin. Okay, so it's a little bit different. You can't just multiply by your scale factor. So I'm going to show you on the front. This is the algebraic method. And then if you flip your paper over, you'll notice you have the exact same page on the back, the exact same examples, except it says graphing method. Okay, so I'm going to show you two different methods for being able to dilate your points or your images when they're not centered at the origin. And then you can decide which method you prefer, and then you can use that to do your practice. Okay. All right, so we're going to start on the side that says algebraic method. Okay, and we're going to look at example 1. So we've got this quadrilateral ABCD. We want to dilate, we want to graph the dilated image of it using a scale factor of 1/2. So is this going to be a reduction or an enlargement? Reduction. So reducing the size. It's going to be half the size. Okay, but with a center of dilation at 1, -2. So if you are not told the center of dilation, it's the origin. Okay, and so when you're reducing or enlarging an image and you're not told this is the center of dilation, you would simply take your ordered pairs and you would multiply them by half, and that would be the location of your new image, scaled by 1/2. But because it's not centered at the origin, there's some extra steps to it. So I'm going to try and break it down and explain the process. When you do this process in future problems, you may not have to write out every single thing I'm writing in this first example, kind of once you get the hang of it. Okay, so what we're looking at here is we are going to I'm going to do 1 point at a time. I'm going to start with point A. Okay, you have to think of it as shifting the entire plane, the entire coordinate plane, so that your center of dilation is at the origin. So if I plotted this center of dilation at 1, -2 for you, if I was going to move everything on here to put that point at 0, 0, how much would I have to move? Would y'all say? Left 1, up 2? Okay, so if I'm going to move, if I'm imagining moving this to make my center the origin, I'm having to move every point on here, left 1 and up 2. Notice that's the opposite of what the location is. The location is +1, -2. So I have to do the reverse of whatever this center of dilation is. Does that make sense? So the first step is to take your X and your Y and do the reverse of whatever the center of dilation is. So in our case, it's going to be -1, which is going to move it left 1, and +2, which is going to move it up 2. And you could see that's what would move this center of dilation up to the origin. So does everybody understand that first part? Okay, so that's what you start with. Then, and so that's coming from your center of dilation. That's why I did this. Then you're going to take your scale factor, and your scale factor, we said in 5.1, is your multiplier. So you're going to multiply by your scale factor, whatever that is. Then, once you do that, since what we started out doing was shifting everything to center it at the origin, now we have to shift it back. So now I have to do the actual direction of the center of dilation, which is going to be to add 1 to the X and subtract 2 from the Y. Okay, and then so you take your original point, you do all of this, and then it gives you your prime. Okay, so if I do this for A, for instance, to get A prime, I would have to go through that process. Are y'all with me so far? So the first thing I'm going to do over here is I'm going to list the location of my pre-image. So A is at -3, 4. Everybody agree with that? So the X is -3 and the Y is 4. So if I were to come over here and I were to plug in -3 and 4 and calculate this, let's see what we would get. So we have to do what's in parentheses first. So that's negative, and we may not have our answer here at the end. Maybe we'll show a little bit more work before we put our final answer. Okay, so when I do that addition, that's -4, and that's 6. And now I'm multiplying by half, right? Okay, so half of -4 is -2, and half of 6 is 3. Okay, and then I said I have to shift it back. So now where does that put me? -1, 1. So now I'm going to plot that. -1, 1 would be A prime. And actually, I'm going to change the color of that since the center of dilation is black. I'll make this some different color. Now, you don't have to, like I said, show this much work for every single problem, but if we were to do the same thing for B, for instance, some of you could probably do this in your head. I'm going to list the point over here to start. Where is point B in the pre-image? 3, 2. So let's just look at one term at a time, just X. So if I were to plug in a 3, 3 minus 1 is 2. Half of 2 is 1. And 1 plus 1 is 2. So for B prime, the X value should come out to 2. Now let's do the Y value. So the Y value starts as 2. I'm adding 2, that's 4. I'm multiplying by half, that's 2. And then subtracting 2. What is that? 0. Okay, and then if I did that for C prime and D prime, I'm going to save you the process, the time, and tell you what those come out to. C comes out to 3, -5. And D comes out to -3, -4. So I'm going to plot all those on here. And I probably should list what the original pre-image C and D are. C was at 5, -8. And D was at -7, -6. So now my new B prime is at 2, 0. B prime is at 3, -5. And D is at -3, -4. So you can see this image. You get that same trapezoid. It is reduced because our scale factor was 1/2. So this was a reduction of 1/2 centered at that black point right there. If you want to keep in your notes, I know I showed plugging in the numbers, but if you want to keep that as your X and Y for the sake of like the formula, that's fine. You can do that. But that's what you're doing. You're taking your original point, you're doing the opposite of whatever your center of dilation is. You're scaling it, and then you're adding in your center of dilation. So you're shifting it to center it at the origin, you're scaling it, then you're shifting it back to the given center. So that's the 3-step process. You'll kind of follow that? Okay. If you wanted to write this, thank you, in terms of, without this specific example, because it's not always going to be -1 and +2 and times 1/2. Okay, those numbers are going to be different depending on what your problem is. So if like at the top or in the margins or maybe at the bottom of your notes somewhere, you want to just put the formula that you're going to use every time if you want to memorize the formula. It's going to be, your scale factor is going to be called K. Okay, and then you're going to have your X and your Y if you're given pre-image point. Okay, and then you're going to be doing the opposite, so subtracting whatever your center of dilation is. We'll call AB. Then at the end, you add back in that A and B. So if you want to write it down like that, you could. If that helps you, you would maybe need to make a note over here that K is your scale factor. AB is your center of dilation. Okay, but that's what you're essentially doing for the algebraic process. Okay, so I'm going to do one more with the algebraic process with y'all, and then I'm going to flip over and show you how to do graphically. Okay, so we're going to use this same formula, okay, on example 2. So in example 2, I'll write it down. My formula what is my scale factor? So that's going to be my K. So K is 2. Okay, and then I'm going to have my X and my Y. Now my center of dilation, so that's what I'm considering A and B, right? So you're going to do the opposite here. So since this is negative, minus -3 just becomes +3, doesn't it? And minus -1 becomes +1. So then at the end, I'm actually going to subtract 3 and subtract 1. Do y'all agree? Okay. So now let's list our X, Y, and Z here. So, and actually we can do it over here. I have room. Okay, so the pre-image, X is at -5, 1. Y is at -2, 0. And Z is at -2, -3. So now, oops, I don't know why I put Y first. Let's do X prime, Y prime, and Z prime. Now, is this going to be a reduction or an enlargement? An enlargement. My scale factor is 2. This should be increasing in size. Okay, so I'm going to take the X value of X, so -5. -5 plus 3 is -2. -2 times 2 is -4. -4 minus 3 is -7. Are y'all with me? If you need to write it out and show that work, you can, or you can do this in Desmos. Okay, but what I'm doing is I'm taking my Y value. My Y value is 1. Okay, so I'm going to plug in a 1 here. 1 plus 1 is times 2 minus 1. Is this making sense? Okay, let's do the next point. I'm going to take my X, -2. If I'm plugging in -2 here, -2 plus 3, that's 1. Agreed? 1 times the scale factor of 2 is 2. And then 2 minus 3 is -1. Okay, now I'm going to take the Y value 0. and plug it in for y. So for my y, 0 plus 1, 1. 1 times 2, 2. 2 minus 1, positive 1. Okay. Last one, negative 2 in for x. So negative 2 plus 3 is positive 1. Positive 1 times 2 is 2. 2 minus 3 is negative 1. Okay, the y value is negative 3. Negative 3 plus 1 is negative 2. Negative 2 times 2 is negative 4. Negative 4 minus 1 is negative 5. So I'm going to plot those points over here. Negative 7, 3. That's x prime. That's my new x. Negative 1, 1. That's my y prime, my new y. And negative 1, negative 5. That's z prime. So now I have this new triangle, x prime, y prime, z prime, that is doubled. It's twice the size. I scaled it by 2. I dilated it by a scale factor of 2, but centered at that point. Y'all with me? So this is the algebraic process. If you like that, you will have to know that formula, or you'll just have to remember the step-by-step process. Okay? That formula we wrote at the top up here. Do we feel okay? Are we understanding that a little bit better? Okay, so you can try number 3 in a minute to practice that algebraic process if you like the algebraic process. But I'm going to flip over to the back and I'm going to show you the graphing method. Okay, I would venture to say about 90% of y'all are going to prefer the graphing method, and that's what you'll do. But if you like that algebraic method, you can do it that way. You get the same thing. Okay, so the graphing method, instead of having to use that formula and do all that math, like you're having to input the x and do the opposite, then scale, then go back. So instead of that 3-step process, you are simply going to measure or count your distance and I'm going to put horizontal and vertical. So count the horizontal and vertical distance of the vertex, whichever one you're focusing on, from the center of dilation, whatever that is. Then, after you have counted that vertical and horizontal distance, you are going to scale those distances. So scaling them means multiplying by the scale factor, right? So I'm going to figure out those distances. I'm going to multiply them by the scale factor. And then I'm going to count the new distance. Very important is that it's from the center of dilation. What I had people doing last class when they were practicing, they were getting the first 2 steps, but then they were counting that new distance from the vertex instead of from the center of dilation. Okay, so I'm going to go through this with you. So for point A, okay, so I'm starting with vertex A. I want to count the vertical and horizontal distance from the center of dilation. So here and here. So that is from the center, I go 1, 2, 3, 4 left. And then 1, 2, 3, 4, 5, 6 up. Do y'all agree? So, ooh, making lots of little marks over here. Okay, so what I'm going to write down is I'm going to write down from A, for point A, I'm going left 4, up 6. Now I'm going to scale those distances. What is my scale factor in this problem? 1/2. So I'm going to multiply those each by 1/2. So what is 1/2 of 4 and 1/2 of 6? So instead of going left 4, I'm going to go left 2. And instead of going up 6, I'm going to go up 3 from the center. So back to the center, I'm going to go left 2, up 3, and that's my new point. That's A prime. I'm going to make this little finer tip on the graph so it's not so jumbled. Okay, so I went over and up to A. I cut that in half and went over and up half of that. Do y'all understand what I did? So that's my A prime. Okay, so A prime, now I have to actually give it as an ordered pair. I don't get to just plot it. So what is that as an ordered pair? At -1, 1. Is -1, 1 the same thing we got on the front doing it algebraically? Yeah, -1, 1 for A prime. So you can count it graphically using the image, or you can do it algebraically like we did on the front. Now I would have to repeat this process for the other points. So like for point B, I would have to go from the center, that's right 2, up 4. So right 2, up 4. I'm going to have to scale that. So what is it going to be when I multiply by half? 1 and 2. So it's going to be right 1, up 2. So that puts B prime from the center of dilation, right 1, up 2, puts me here at 2, 0. Is that what I got doing it algebraically? Are we getting the idea of this? Okay, 2, 0. Yep, I got the same thing, 2, 0. Do y'all need me to show you doing C and D as well, or do you understand the process?
We understand.
Okay, so you can do the same thing to check 2 if you wanted. I want y'all to try example 3 in the method you want. So either try it on the front using the algebraic method, or try it back here using this graphic method. Okay? So I'm going to give y'all a minute, and then we're going to check number 3 to make sure y'all got it. Okay? If you are watching this as a video, I'm going to stop the video here. I'm going to post the completed notes with everything worked out, so you can just go and check against those posted notes to see if you got example 3 right in whichever method you tried. Okay, once we check this one, after you've checked it, then you're going to be doing the practice. Your practice is in Delta Math, or excuse me, I said that backward. It is not in Delta Math. It is a Canvas assignment. So you'll go to Canvas. It's linked in the calendar, or it should be on your to-do list or your assignment list. It is only 5 questions. And instead of giving you, I need y'all to stop talking. I am still talking to y'all as a class. Your assignment, instead of giving you a shape like this with multiple vertices that you have to move, it just gives you, there's no picture. It just gives you an ordered pair of a starting point, A, and it gives you a scale factor and a center of dilation and asks where A prime would be. Where would A be located now after the dilation? Okay, so you're just doing 1 point at a time per problem. Okay, and you can use the algebraic method, or if you want to use the graphing method and it's not a picture graphed for you, your options would be to graph it on graph paper. I've got scratch graph paper back here. The whiteboards that I have for y'all to work on, they are double-sided. One side has a grid, so you could do it on the whiteboards that are gridded. Or you could go in Desmos graphing and plot your point A and your center of dilation and count it on the screen on your graph. You're not going to be able to do that on your test. You're not going to have a graphing calculator on your test. But just instead of graphing on paper, if you want to graph on Desmos just to plot your points and count, that's a fine option. Are we good? Okay.